Hello friends, welcome back to our channel. So today we'll see one more problem in traveling salesman problem. So in our previous session we have seen what is a traveling salesman problem and we have solved one example which is an undirected complete weighted graph. Now in this session we'll see one more example which is weighted directed complete graph. So we have seen the difference between a complete graph and a normal graph, and also weighted graph and unweighted graph, directed and undirected, right? So now we will solve this example, right, by using the dynamic programming. First let us write the adjacency matrix and we'll erase this one because the board is very short. So I'll write the adjacency matrix and I'll erase the complete thing, right? I'll write the adjacency matrix here. So A, B, C and D. So 4 vertices. So we'll write the cost from one vertices with another one. So A to A, so which is always 0, and A to B. So A to B it is 10, A to C it is 15, A to D it's 8, B to A 5, B to B 0, B to C 13, B to D it's 10, C to A it's 6, C to B it's 9, C to C 0, C to D it's again 9, and D to A it's 20, D to B it's 8, D to C 12, and D to D is 0. So this is the adjacency matrix, right? So I'll erase this one. So which is an weighted directed complete graph. Now first we'll write the formula. So we need to remember two formula before starting the solution, right? So G of I comma set of S is equal to minimum of J belongs to set cost of Ij plus G of J comma set minus J. This is one formula. And another formula, so cost of or G of I comma pi is equal to G of I comma cost of I comma source. So we need to remember these two formula before starting the solution. Now we need to find the minimum distance from source vertex visiting all other vertices at least once, exactly once, and come back to the source vertex. So we'll see the source vertex as A. So we can consider any vertex as source vertex. So the first step we have seen in our previous session, that is we need to select the source vertex. So here I will select the source vertex as A. Now we need to start from A, visiting all nodes and come back to A with a minimum distance. So we'll write the next possible source, unvisited. So first one, let us take if set is equal to 0, that means no unvisited vertices. If there are no unvisited vertices, then the recent vertex will be the last vertex. So the possibility is G of B comma phi, because itself is the last vertex. So what is the formula of this one? G of I comma phi is a cost of B comma source. Here the source is A, cost of A. B of A, cost of B comma A. So we can write simply it as G of B comma A, which is B to A, it's a 5. Similarly, if the last vertex is C, then obviously if the last vertex is C and there are no unvisited vertices, then immediately we need to reach the source. So that's what the problem. So we need to start from source, visiting all the vertices exactly once and come back to the source. So if the last vertex is C and there are no unvisited vertex, so obviously we need to go to the source. So G of C comma source. So CA, which is a 6. And the next possibility D comma pi is equal to G of D comma source. So it is 20. Okay. So the only possibilities are this one. The only possibilities are this one. Now let us assume if set contains 1. 1 means unvisited vertex are 1. So I'll write here 1 unvisited vertices. 1 unvisited vertex. Okay. So for example, if we are at B and there is only one vertex, so what are the remaining vertex? For example, if we are at B, what is the remaining vertex, unvisited vertex? It may be C or it may be D. For example, if our graph is having one more vertex like this one, B, C, D, E, right? So if our graph is having one more E, then there is a one more possibility E. So we need to check the cost for each and every edge. If B, B to C, B to D, B to E. That means the set contains only one unvisited. Only one unvisited. So if we are at B, the unvisited can be C. And similarly, if we are at B, the unvisited is D. So two possibilities. So we are at B, so unvisited vertex, it may be C or D. So we need to find out this one. So what is the formula? Minimum. So here we are set is having only one element. So we need not write this minimum because we will get only one formula. So C of BC plus function of, what is this one? Consider it as a J. So J, that means C comma G of J comma C comma set of C minus C. Set of C minus C. So this can be written as a pi. So obviously, so we can replace this one. So we are having the set as C. We have to subtract the C itself from the set. So the remaining is pi. Okay. So what is the amount here? What is the cost here? CBC. What is the BC cost? B to C 13 plus G of C comma, sorry, yes, this is the thing I have written wrong. So G of C comma pi. Okay, C comma pi. So what is the value of this GC pi? Already we have calculated here. So that's what we are saying in the dynamic programming. So the complex problem will be divided into subproblems and we are solving the subproblem and we are storing the result so that in future if it is required, so we can make use of the value from the memory. So here already we have calculated, so we need not calculate once again. So we can simply use this value 6. So here 13 plus 6, which is 19. 13 plus 6 is 19. And now let us calculate the second thing. So the next possibility, B comma D. If the unvisited vertex only one is D, then C B D plus G of D comma pi. Because the set is having only D and we need to subtract the same vertex from the set. So which is nothing but pi. And here what is the value? BD, HBD, B and D. It's a 10 plus G of D pi, which is 20. So what is the value here? 30. So we need not select the minimum because only one calculation. This is one edge and this is one edge. Okay. So this is 19 and this is 30. So now change the vertex. If we are at C, the possibilities are B. Okay. So cost of CB plus G G of B comma pi. So which is a cost CB, it's 9 plus GB pi, it's a 5, which is 14, which is nothing but 14. And the next possibility, G of C comma D, if the unvisited vertex is D. So cost of CD plus G of D comma pi. So cost of CD, edge C, D is 9 plus G of D pi, 20, 29. Okay, so we have completed the two vertices. Now if the vertex, we are at D, if we are at D, so G of D comma, the possibilities are C, so which is cost of DC plus G of only one element, so C comma pi. So DC, it's a 12 plus C pi, which is 6, is equal to 18. And there is a one more possibility, if we are at D, the next unvisited can be B. So C dB plus G of B comma pi. B comma pi. Then see dB. So dB means 8 plus G of B pi, which is a 5. So which is 13. So we have completed all the possibilities if unvisited is one vertex. If unvisited, so just listen carefully. So if the set is having only one unvisited and we are at B, then the possible unvisited vertex will be C and D. And the next possibility, if we are at C, the next unvisited will be either B or D. And if we are at D, the next unvisited will be either C or B. So we are calculating for all the possibilities. Now, so we have calculated all the possibilities if set is equal to 1. Now calculate with set is equal to 2. That means if set is having two unvisited vertex, two unvisited vertices, right? Now calculate G of B, okay, comma, if the set is, if we are at B, the next two unvisited can be C comma D. Okay, C comma D. So how we can write this one? So G of, we have to write down this formula. So we are having a two possibilities, two edges. One is BC, another one is BD. So among that we have to select the minimum. Okay. So previously in the set we are having only one unvisited vertex. So we need not calculate the minimum because we are having only one edge. There is the possibility of having one edge. But here we are having in the set two unvisited vertices. So that means there will be two possible edges. So among those two possible edges, we need to select the minimum one. So how we can write? So G of, I'll write here, okay. So minimum of cost of BC, cost of BD. So these two are the possibilities. Plus G of, okay, what's the formula? G of J. Here J is C. C comma set minus J. So set minus, here the set is having two elements. So set minus C. Obviously it will be D. And here also G of, here J is D. So D comma set minus D, it will be C. So we need to select the minimum cost among these two. So what is the cost of this one? So BC, okay, BC, B to C, it's 13 plus G of C comma D. Already we have computed this one. G of C comma D. So G of C comma D, which is 29. So this will be 29. So 13 plus 29, right? So that will be 42. Okay, and what about this cost? C of BD. BD, it's a 10 plus G of DC, already calculated. DC, which is 18. So the cost will be 28. So among these two, which one is the minimum? So this is the minimum value. Okay, we need to select that one. And next, so this is the possibility. If we are at B, the next possible edges will be either C and D. Now, G of, if we are at C, the next possible unvisited are B and D. What we have to do? So minimum of cost of CB and cost of CD, and here the J value is B, so B comma, from the set we are removing the B, so the remaining is D, and here it is D, and in the set, from the set we are removing the D, so it will be B. So what is the cost? Cost of CB, what is the CBH? 9, so this is a 9 plus G of B comma D, already we have computed, so BD, so this one 30, which is 39. And what about this one? CD, C to D, it is 9 plus DB, here DB, which is 13, which is 22. Right? So among these two, which is the minimum? This one is the minimum. This one is the minimum. Okay. So among these two, this is the minimum. Among these two, this is the minimum. So if we want to consider the edge, we have to consider this edge. That means C to D. And if you want to consider here the edge is B to D. Okay. Now, so what happens here? Again, check one more possibility. So there is one more possibility. G of, if we are at D, the next possible edges will be B comma C. So how we can write it? So minimum of cost of DB and cost of DC plus G of, here B is a J, and from set remove B, so C, and here also G, the J is C, from set remove the C, so it will be B. Now calculate the cost. DB, so DB, which is 8 plus G of B comma C, G of B comma C, which is 19, which is 27. And what about this cost? DC, D to C, 12 plus G of C comma B, G of C comma B, which is 14, so which is 26. So among this one, this is the minimum. Sorry, this is the minimum. Okay, this is the minimum. So if you want to consider the edge, we need to consider D to C. Okay, so here we have completed the set 2. That means set of 2 unvisited vertices. Now we will see set of 3 unvisited vertices. So if S is equal to 3, so 3 unvisited. So what is the possibilities? So G of, so 3 unvisited vertices means B, C, D, because in our graph we are having 4 vertices. Among these 4 vertices, 1 vertex we are considering it as a source, and remaining 3 are the unvisited vertices. So simply here we can write it as source, and in the set B, C, D, all the 3 are unvisited. All the 3 are unvisited. Now what we can do here? So we can write it as minimum of cost of AB, cost of AC, cost of AD plus G of here J is B, so G of B minus set minus J, set minus B. Here the set is having BCD, among that we have to remove the B, so it will be set of C comma D. And here also G of C comma, and here the J value is C, from set we have to remove C, so it will be B comma D. And here also G of J value is D, and we have to remove D from set, so it will be B comma C. Now calculate here, right? So we need to consider the minimum among these three. So CAB, that means edge AB, A to B it's 10 plus G of B comma CD. Already we have computed this one. G of B comma CD. Okay, what is the value? So we are having two values and we have to consider the minimum. So among these two, 28 is the minimum. So we have to consider 28. So the result is 38. And coming to this one, A to C. So A to C, it is a 15. 15 plus C comma BD, already computed, C comma BD. Here also we got two values. Among these two we have to consider the minimum. What is the minimum value? 22. So here we need to give 22, which gives 37. And coming to this one, A to D, which is 8 plus G of D comma BC. D comma BC, among these two the minimum cost is 26. Consider 26, which is 34. Okay, so among these three values, which one is the least? 34 is the least, right? So we have completed this one. There are no other possibilities because the source, from source, let us consider all the remaining three vertices are unvisited. So that also we have computed. So we need to stop here, right? Now we need to find out the path with the minimum distance. So what is the minimum distance among these three? So only 34. We are getting 34, right? So all the remaining values, that means remaining 37 and 38, both are greater than 34. So here we are having only one path with a minimum cost, that is 34. Now we have to write down the path. So what is the edge of this 34? A comma D. So from source, the next visited vertex is D. Okay, next visited vertex is D, and then we need to find out the next edge from this function GDBC. Go to here, GDBC. Which one we have considered? This one. So from D, next vertex is C. So we have to consider this DC. The next vertex is C, right? And again go to this function for finding the next edge. So from C, next edge C to B. So go to here, C to B. So edge is C to B. That means B. Okay, B, because here we are having only one value, right? So go to the B to 5. B to pi. The next edge is A. So obviously it will return back to A. So here the cost is 34. So this is the shortest path. Okay, the shortest path means, so minimum distance visiting all the vertex exactly once from the source and coming back to the source. Now we'll see A to D, it is 8, D to C, it is 12, C to B, it's 9, and B to A, it is 5. So you can consider 8 plus 12, 20, 29, 29 plus 5, 34. So which is this one. So we need to consider this edge. And from this, we have to consider this one. From this, we have to consider, so C comma B, this one. And from this, we have to consider this one. So these are the edges. So this is the order we have to, the salesperson or the salesman traverse the vertex with a minimum distance, right? So if you are having 5 vertices, the one more calculation will be there. So this is the one more calculation, and after that we'll get the final calculation. So once practice with on any random graph considering more number of vertices, so that you will be getting understandable. So you will be understanding very easily, right? So be careful while calculating or by performing these additions, because if anything wrong, if anything gets wrong, automatically the final result will be deviated. Okay, so hope you understood and enjoyed the session. So let's stop here, and if you are having any doubts regarding this procedure, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.